Hi, this is Sapna Bharti and we are here at VMworld in San Francisco. And today we have with us Janakiram. You're an independent analyst and advisor. And I have been reading your work, and we have known each other for so long, but we never got to actually meet in person. Interesting, let alone sitting and actually talking on the video. So this is a great opportunity for us actually to discuss some, latest buzzwords or topics. So first of all, thanks for coming to the show.
Oh, my pleasure. I've been a fan of your work, and it feels great to be a part of TFIR. So VMworld is exciting. And what I'm going to talk to you about is the convergence of two interesting technologies. One is IoT, which is redefining industrial automation and Industry 4.0, and the other technology is AI. So one of the emerging buzzwords, jargons that is becoming very, very hot and most discussed is AIoT, the convergence of artificial intelligence and IoT. So, I've been tracking this space for a while. So the way I have seen this evolve is earlier when cloud became prominent and mainstream, it opened up access to tremendous compute power and storage. So a lot of customers started to look at cloud for connecting their devices because cloud provided them 24/7 connectivity, and they were not worried about uptime. So devices were connected to cloud, and these devices could talk to each other over cloud as a channel. That was the first entry point of IoT via the cloud. Then once the M2M, as they call it, which is machine-to-machine communication, then customers started streaming the telemetry data from the sensors and devices to the cloud because storage was very cheap. You could literally store gigabytes and petabytes of data for just few cents and few dollars. So cloud became the destination for a lot of telemetry data. And once the telemetry data started flowing in, the next obvious thing was processing the data. And because compute was very close to storage, customers started tapping into big data, Hadoop clusters, and Apache Spark-based clusters to start processing the telemetry data that hit the cloud. And that was the first generation of Internet of Things. So there were three things. One, device connectivity. For example, a shop floor sitting in one part of the city could actually talk to the manufacturing unit, which is at the other end of the city, and cloud was the conduit. That was the first benefit. The second benefit was abundant storage. And the third benefit was very affordable compute that could process this data. And this literally became a new workload for cloud providers like Amazon, Microsoft, IBM, and Google. So IoT has become like one of the drivers for compute and storage. They could literally sell more compute, more storage by positioning IoT as a solution. So it has become a new workload. That was the first generation of IoT. The second generation of IoT was now that customers started streaming the data, how can they reduce the latency and how can they reduce the spillover of data? Because if you take an industry like healthcare, they don't want to stream very sensitive, confidential patient data to the cloud and process that somewhere in the cloud. It was very risky. It violated a lot of policies and a lot of regulations, and customers were not comfortable moving sensitive data from their devices and sensors all the way to the cloud. So they came back and asked cloud providers on what can we do to avoid streaming the entire telemetry data? Can we filter that? Can we do something locally so that we can avoid the round trip to the cloud? And then came in the concept of an IoT gateway. So IoT gateway was sitting right in between the devices and the public cloud, and it offered two advantages. One, it actually filtered the data so that not every piece of telemetry data hit the cloud, so it saved a lot of bandwidth. Second thing is customers could anonymize the data, could process the data locally instead of sending everything at once to the cloud. And it also solved the problem of protocol translation because a lot of legacy devices in industrial automation use BACnet, Modbus, CAN bus, and very legacy protocols that predate cloud. And cloud doesn't understand any of these protocols. So the gateway device that they deployed could effectively translate these legacy protocols like OPC, Modbus, and CAN bus and translate that into more contemporary protocol like REST or MQTT or Kafka and so on. So This device that sat in between the equipment and the public cloud was termed as IoT gateway. So it translated the protocols, it converted the data, it filtered the data, and gave some kind of a local processing. But the IoT gateway didn't really do anything useful other than just applying these filters and routing the data or translating the protocols. That was the second generation of IoT. The third generation of IoT was, how do I bring more muscle, more compute capability to my gateway so that I can start running business logic? And that's the time when compute was slowly shifting away from virtual machines to containers to serverless functions. And that was an opportunity for both cloud providers and industrial consumers to bring in additional compute power to the IoT gateway. So Amazon took that route and launched Greengrass, and Greengrass became the IoT gateway that could run Lambda functions, and that was Amazon's way of bringing compute closer to devices. Microsoft had a very similar approach, and they took the route of containers. So IoT gateway started doubling up as a local compute unit, and it could run either containers for compute or serverless for compute. And with that addition, there were other things that came in. For example, stream analytics. Can I run stream analytics and query the data more effectively? And can I actually run an S3 compatible layer so that I can store the data? So gradually, the IoT gateway started to mimic the public cloud. And it assumed some of the capabilities like compute, storage, and even networking, because customers wanted this device to participate in an existing subnet and existing network topology. So quickly, the IoT gateway started mimicking the public cloud. So it had storage, it had compute, it had network, and the industry was also experimenting with this new topology and a terminology called fog computing and edge computing. That was the best time for cloud providers like Microsoft and Amazon to graduate the IoT gateway into an edge computing layer, because it is no more a protocol translation gateway, it was no more a conduit, it was more of an intelligent compute device that sat close to the devices. So that is the third generation of IoT, where Internet Gateway has graduated into an edge computing layer, and it did everything that the Internet Gateway did, but also offered more computing power locally, so you could actually run business logic. And that's where we are today. The edge computing that we are talking about is a mini public cloud that is running close to the devices. It's actually called as a device edge. While this was happening, there is another very interesting trend that took place. The whole question about the value of big data and the whole challenge of Cloudera and Hortonworks, and the question of the value of big data started to come in. And AI has become the means to an end. The means is big data, the end is AI. Big data really didn't define an outcome. Okay, you have a lot of data, the telemetry data that came in from devices. We have data lakes, we have petabytes of data, but what can I do? Running a Hadoop MapReduce algorithm didn't answer a lot of questions. It didn't really deliver the value. It didn't substantiate the compute investments that customers did. And then AI slowly became the end, while big data was the means to an end. And IoT was a perfect use case that solved both the big data problem and also the AI problem. Now, with so much of data sitting in the public cloud, and the rise of machine learning, deep learning, and AI helped public cloud providers to demonstrate the value of data sitting in the cloud. So SageMaker came in, Azure ML came in, IBM Watson came in, and then Salesforce has launched Einstein. So a lot of deep learning algorithms started to surface in the public cloud, and they actually use the data that customers started streaming in and collecting in the public cloud. So quickly AI became a new workload, and that consumed a lot of compute, a lot of storage. and they started to answer a lot of questions for customers, like forecasting, like anomaly detection, performing root cause analysis. And suddenly everyone saw value in big data, not in the way it answered the current questions, but the way big data could make AI more valuable and make it more meaningful. So AI fits in very well in the context of industrial automation and predictive maintenance. So both the first generation, second generation, third generation of IoT had rules engine that actually said, if a sensor's data hits this threshold, do something. Right? For example, if the temperature of my furnace goes beyond X, shut down the furnace before it really does something fatal. But that was a very hardwired business rule that was running in the IoT gateway or edge or in the cloud. Now, thanks to AI, instead of having that hardwired rules engine, you could actually deploy a model and let it get trained over a period of time, so that you're not hard coding the logic or the rule, but you are letting the machine learn its own pattern over a period of time. Now, this AI model was trained in the public cloud and it was running in the public cloud, and the sensor data was sent there. It could either infer in real time, or it could collect the data over a period of time and learn over a period of time. But the bottom line is, IoT was starting to take advantage of AI via big data and data lakes. Now, when customers saw that AI is helping them do predictive maintenance, for example, they could figure out when the machine is going to fail and what sensor is going to hit an anomaly, they saw a lot of value. But this round trip of going to the cloud, getting an AI model applied, and coming back with the result was taking too long, and it was too sensitive for customers to run these AI models in the cloud. So they wanted the AI models to run at the edge. And edge, the capacity, the capability of edge was not just sufficient to run an AI model. So Amazon started to come out with this snowball edge, which is a heavy edge. And it actually comes with GPUs and FPGAs, and it is quite capable. It's almost like a mini EC2 instance running edge close to the devices, and it is capable of running a full-blown machine learning model. And Microsoft started to ship something called Data Box that comes with an Intel FPGA, and it is again like a very powerful machine that is running, of course, the edge, the IoT gateway, but also the ability to run ML in real time. So now what happens is, instead of the rules engine that was static and someone had to program and rewire, is now extremely dynamic. So you train a model in the public cloud, you define an algorithm, you train the model, and then you run it at the edge, and it will infer in real time. And when it detects that the predictions are not very accurate, it goes back, uses the previous data lake data stream, gets trained, and again gets deployed to the edge. And this cycle automatically takes place. It's like CI/CD for machine learning. The only difference here is the trigger is not a git commit. The trigger is drift that happens between the actual values and the predicted values, and that will trigger a new retrain pipeline, and the outcome of that pipeline is a new model that gets deployed onto the edge. And this is where IoT and AI are meeting, and this is the new era of AIoT, artificial intelligence of things. And this is going to replace the static rules engine that has been traditionally embedded in IoT platforms. This is going to replace reactive maintenance with predictive maintenance. Reactive maintenance is when something goes wrong, do this. Predictive maintenance is detect when it is going to go wrong and do this. So AIoT delivers predictive analytics and predictive maintenance of devices, and it also brings in a very important aspect. So Internet of Things basically is all about connect, collect, and process. Right? You connect the devices with each other and you let them talk to each other. Then you collect the data that is getting emitted by these sensors and devices, and then you process that to get a very powerful, nice Power BI or a Tableau dashboard. But ultimately, when an anomaly is detected, it is left to the operator or the field engineer to take an action. So it is enabling a human to make better decisions, and the loop ends with that. Now, when you deploy AI, you're actually bringing in brains to this entire cycle. So instead of letting a human look at the dashboard and make a decision, you are letting an AI engine take that action. So instead of expecting a human, a supervisor, to look at a dashboard and figure out that one of the devices is malfunctioning and then manually shutting it down or using the M2M to shut it down, you're deploying an AI which will close the loop. It will not only detect that it is actually malfunctioning, it can act upon the equipment and shut it down or take a proactive step. So it closes the loop by adding the act step to the collect process, collect process, and then act, which is decision making and acting upon the devices. And this is the power of AIoT, the convergence of IoT and AI, which is artificial intelligence of things. And this is where edge computing becomes very, very powerful and very useful. Now, what happens is when we deploy edge, it is powered by either an ARM processor or an x86 processor. And these processors are not designed to deal with highly customized, purpose-built deep learning models. For example, when you connect a camera and you want to detect what kind of a vehicle is passing by the toll gate or on the highway, a CPU might take much longer to really perform that object detection. Now, these generic CPUs need to be complemented by specialized accelerators that can speed up inferencing and can speed up object detection and classification. Typically, this is where GPUs come in. NVIDIA is doing very well in that space, but these edge devices are not powerful enough to actually run a full-blown Tesla NVIDIA GPU. So you need to have much smaller form factor that will consume much lesser power, because who knows, this might be deployed in a windmill that is very difficult to access. It might be deployed in a ship that is somewhere in the middle of the Pacific. So you don't have the luxury of managing those devices and updating the software often, and you don't get a lot of space to deploy these devices. So it has to be very compact. So that's where we started to see AI accelerators, the market for AI accelerators come in. So today Intel is shipping these accelerators in the form of Myriad X VPU. VPU is Visual Processing Unit. It complements the x86 CPU or an ARM CPU. NVIDIA is shipping something called Jetson family of products, Jetson Nano, TX2, and so on. Qualcomm has its own family of AI accelerators. And then Google has got into the game by shipping Edge TPU that will accelerate AI models at the edge, and it complements CPU. Now, one of the biggest driver and the key building block of AIoT is an accelerator that gets attached to the edge computing layer. So when you add the accelerator either through an USB form factor or a mini PCIe form factor, it speeds up inferencing dramatically. So the combination of x86 or an ARM CPU with an AI accelerator and the edge computing software delivered by one of the public cloud providers and the AI model that is responsible for performing this predictive maintenance or anomaly detection, combined with rest of the compute, storage, and network platforms, is the new generation of edge computing devices. And the biggest driver and the key building block here is AI, which is software plus the hardware that is coming as an AI accelerator. And this market is so big that everyone is literally creating a new SKU or a product family for that. For example, Dell is really shipping gateways and edge devices, which is going to be like a new market segment for them. And Google is also getting into that game, and Microsoft, Amazon, they're already there. So the whole convergence of IoT plus AI, both the hardware and software elements, is very exciting, and it is opening up a lot of avenues. For example, when we get into connected cars, the connected car is literally an edge computing on wheels. It has, tens of thousands of cores that are actually processing the data as it comes in. And that is one classic example of edge computing on wheels. And similarly, aircrafts will run edge computing, and a lot of vehicles will run. And industrial equipment will, for example, the Honeywell and the GE machinery that is being created will actually have an edge computing layer attached to them so that they can process the data at the origin, and they are capable of running AI, and they have accelerators. So there is a dramatic shift in computing through AI and through AI accelerators. So this whole new world where we are talking about processing the data as it gets generated and accelerating that whole process and applying artificial intelligence and bringing brains into IoT is AIoT. And this is very fascinating world. And it aligns really well with the Industry 4.0 revolution.
That was amazing, John. Thank you so much for talking about this. And I mean, I'm really kind of, that we should actually meet more often.
Absolutely.
So once again, thanks for taking your time out and explaining this. Actually, you gave the whole evolution of IoT and edge computing, which is a kind of edge computing became a big buzzword where people are still trying to define what is edge computing.
Right.
But you encapsulated everything very nicely. So once again, thank you.
Cool. My pleasure. Thank you.